Howdy, y'all. Welcome back. Estimating square roots. I promised it. Here it is. Time to deliver. On the right side, you can see the same notes that we had for the last assignment, reminding us of what the perfect squares are from 1 to 25. At one point in my nerd history, I had memorized all these. Still know most of them. Some of the tougher ones, like 23 and 24 squared, probably escape me, but 25 squared, 625. That's pretty easy to memorize because it's got a 6 in front and it's just 25 at the end. But yeah, there you go. If you're bored and want to memorize those, it's kind of fun. Let's dive right in because not all square roots of integers end up being perfect squares. That's for darn sure. We're going to talk about those today. So when you open number 1, you're going to see a number, and unless you have some rare glitch, it is not going to be a perfect square. Instead, like mine says, the square root of 3. I need to find, looking at the perfect square side, where 3 falls in between perfect squares. So 3 is between 1 and 4. That means that the square root of 3, if I go to the left side, is between 1 and 2. And I can clarify that. Check it out. If I take the square root of 3 on the calculator, it's going to give me a decimal that, is in between 1 and 2, 1.73. So then I need to put, since it's between 1 and 2, 1, comma, 2. Next, I could look at the square root of 18. All right, let's go down. It's greater than 1, it's greater than 4, it's greater than 9, it's greater than 16, it's less than 25. Okay, it's between 16 and 25. So that means if I take the square root of those, it's between 4 and 5. And once again, I can take the square root in my calculator, and it's going to tell me 4 point something. 4.24. So it's between 4 and 5. 4, comma, 5 is my answer. It's as simple as that. You can either use your decimal when you type it in your calculator or this perfect square chart to match it up. Same thing with number 3, square root of 56. 56 is larger, smaller, in between 7 and 8. And pause this video if you need more time with this perfect square chart, because I am going to close it, at least go to my calculator, because now I'm in a situation where it says use a calculator to approximate each square root. Round your answer to the nearest tenth. We're going to be rounding. Also notice this super weird calculator thing that comes up. This confuses everybody. Don't worry about this. Ignore it. Just keep scrolling down to where you see our regular old answer blank right there. Square root of 46. Well, 46 is between 36 and 49. It's much closer to 49 than 36. So we're going to play a little game here. I'm going to try and guess to the nearest tenth, that's one decimal after, what the square root of 46 is. If it was right in between 6 and 7, like say it was like 42, 43, somewhere in there, I would say that it would be like 6.5. But because it's closer to 7, I know that that decimal is going to be greater than 5. So I'm going to guess 6 point... I'm stuck between 8 and 7. Let's go 8. I'm nervous. Am I going to be right? Am I going to be right? Come on. Well, let's look. Little rounding review here. I skipped through this very fast before when we had quadratic formula. I apologize for that. There's just so much going on. I didn't want to spend a whole lesson on that. Rounding to the nearest tenth means no matter what, it's either going to be 6.7 or 6.8. The question is it going to stay, that's 6.7, or is it going to round up to 6.8? Here's what we do. We ignore every digit past the first one. I don't care if it makes that one round up or whatever. That confuses people. Just ignore it. Instead, I need to look at this number to the right of my wall, this 8, and here is the question you need to ask yourself. You say, self, is this number, this circled number, that's a terrible circle, I'll just leave it pointed, is that number 5 or above, meaning 5, 6, 7, 8, or 9? If so, then we give this 6.7 a shove up to 6.8. However, if this number to the right is 4 or below, that's 4, 3, 2, 1, or 0, then we leave this 6.7 a low. No. So 5 or above, give it a shove. 4 or below, leave it a low. No. This is 5 or above, so we need to round 6.7 up to 6.8, which is exactly what I guessed, right? If I said 6.7, then whatever. I meant 6.8. 6.8. All right, that's my fun little game. And I was going to leave down the perfect square chart like I said I was, but because of the game, let's bring it back. Let's bring it back and try the next one. My internet's being slow. Okay, square root of 13. So that's between 9 and 16. 13 is 4 greater than 9 and 3 less than 16. So it's a little bit closer to 4 than 3. Therefore, I'm going to say 3.6. 3.6. And yes, that number to the right of the 6 is a 0. That's 4 or below, so I leave it alone. No, to 3.6. Okay, we're cooking. 279. Whoa, 279. Let's go to the right column for this one. That's greater than 256 and less than 289. 279 is 23 more than 256, but only 10 less than 289. So it's going to be closer to 17 and 16. I'm going to go 16.8 again. 16.8. 16.7, because that 0 is not 5 or above. It doesn't get a shove. Drat. I lost my little hypothetical game here. Just fun to play. I enjoy this kind of stuff. Especially when you know you've got no pressure. If you're wrong, it's not like you lose points. You just input the right answer. And really, when you're exercising your brain, you're right, whether you guess it correct or not. The last one before we get into our old sad me algebra problems. 212. Let's see if I can end on a high note here. 212 is most assuredly between 196 and 225, so it's going to be between 14 and 15. 212 is 16 greater than 196 and 13 less than 225. So it is almost right in the middle, but a little closer. So I'm going to say again, please don't round down to 5. Show me 14.6. Yes! Darn you, but thank you for rounding. Last time I didn't appreciate it, now I do because that 6 is 5 or above, so we got to give it a shove up to 14.6. Clutch, 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 clutch. Got it. All right. 8, 9, and 10. Notice we've got no extra bonus problem today for 11 like we did last assignment. That means we can just roll on out with a little sad me. Let's remind everyone at home what that is. That's backwards PIMDOS. But because we have no parentheses in these problems, it's backwards IMDOS, which is sad me. Standing for subtracting and adding, then dividing and multiplying, and finally doing exponents. We're starting out with a Texas two-stepper. We got some subtraction and addition to do. Always the opposite, always to both sides. X squared is 26. Notice how I go from top to bottom each time, perfectly on each side of the kid. You got to give the kid the same thing on each side or it starts a war. Not good. We have subtracted and added. Now we need to divide and multiply. Oh wait, we don't have anything to divide and multiply, so we good. So we just have to do our exponents. Our exponents are the square root of 26. Ooh, well, my chart isn't in front of me, but I know that 5 squared is 25, and 6 squared is 36. So 26 is between 5 and 6 squared, and it's almost exactly, it's as close as possible to 5 squared. It's close as possible to 25. It's 26. So does that mean it's going to be less than 5.1? Is it going to be 5.0 even rounded? 3, 2, 1, gone. Let's see. Are you going to show us our first rounded down to the 0? Or is it going to be the 1? Oh, nope. It's not a 0. That 9 is as close as it gets to being 5.1 naturally without rounding. Now check this. 5.1. Do not forget, if you already have out there and you're cursing to yourself, I'm sorry. You hit check too fast. Always wait for me to hit check because you forgot, just like last time. that we got to put the negative, because negative 5.1 rounded squared will also give you 26. Not perfectly because it's rounded, but we got to put the negative. Same thing for 9 and 10. We must put the negative each time. Okay, number 9. 9 is itself a perfect square, so that's very fitting that we're on number 9 talking about perfect squares, although we're talking more about imperfect squares right now. And actually, I am going to, before I even start writing, let's leave these up. And then we'll switch into our calculator. Okay. Sad me. We first got to subtract and add. 112 minus 24 is 88. That equals 4x squared. We divide both sides by 4. 22 equals x squared. We take the square root of 22. Let's look at our chart because we left it up. 22 is between 16 and 25. 22 is 6 greater than 16, and it's 3 less than 25, so it's definitely going to be above the 0.5. I'm going to go with it's either 7 or 8. I'm stuck again. It was 0.8 last time, so let's go 0.7 this time. If it's 0.8 again, I'm going to go 0.8 every time. Show me 0.7. Yes! 6 rounds up to 7 because 9 is indeed 5 or above. 4.7, comma, negative 4.7. Got it. Got it. And that leaves number 10. 2x squared plus 1x squared is 24. That's right, I said 1x squared even though there's not a 1 there, because if there's no numbers, it's just 1. The same way you are one of whatever your name is. Like I'm one Dylan. They don't call me one Dylan, they just call me Dylan. It's redundant. Even more than that, it's rewundant. Puns for days. Okay, these are like terms on the left side. 2x squared and 1x squared. Think of these not as x squareds, because sometimes that's confusing. Think of these as cows. If I have 2 cows plus 1 more cow, I have 3 cows, right? So, likewise, if I have 2x squareds plus 1x squared, that's the same thing as having 3x squareds, equaling still 24 on the right. Now it's just a simple Texas two-stepper. We got the rabbits. They're doing their thing. They're multiplying. So we divide 24 divided by 3 is 8. We take the square root of 8. I closed my table, but I know that 2 squared is 4 and 3 squared is 9. And that 8 is as close to 9 as we can get. But there's only 5 numbers in between 4 and 9, so I'm going to guess 2 point... It's either 8 or 9? 9? I mean, that's as close to it as possible, right? Let's see. 3, 2, 1, blammo. Again, rewind if you need more time. Show me 2.9. No, it's 2.8. Meaning there is no 2.9. Even though it's as close to it as possible. They're just too small. Oh, no, I forgot the negative. Well, you know, when this happens to me, this is good luck. Because now I get to try and guess correctly and go out on top. All right, let's do this together. 2x squared and 2x squared is 4x squared. So I do 56 divided by 4. 56 divided by 4. What's that like? 14 or something? Yes, 14. So the square root of 14. Okay, let's think about 14. 14 is in between 9 and 16. It's 2 away from 16. It's 5 away from 9. It's not directly, that's not like 15. So I'm going to go 3.7. 3.7. Go out on top. Please, please, please. I'm so nervous. 3.7. Yes! Oh, look how close that is. That 4 is so close to 5. We're so close to rounding up to 3.8. Now that I'm out on top, I'm going to remember to put negative 3.7, and I am going to gloat my way to the end of this video because I got redemption. I got redemption. I'm so glad I missed that problem. See, sometimes failures can be wonderful. Not only do you learn from them, you get a chance for redemption. 100% done and done. Happy May, by the way, when I'm filming this video. No idea when you're going to watch it, but it's May 2020. Same month that my daughter's going to be born. So exciting. Okay. Much love to you all. Hope this video finds you safe, well, and that you are on fire with these problems like I was, at least the ones that I guessed right. Have a great life. Everything. Hope it goes well for you. Peace.